Thank you for joining this lesson. We are going to answer a question from the oil drop experiment. We are told that in an experiment to estimate the size of oil molecule, an oil drop of diameter 0.05 centimeters spreads over water to form a circular patch whose diameter is 15 centimeters. Then we are told part A to determine in SI units, Roman 1, volume of the drop. There are some assumptions which are made in the oil drop experiment. For example, we assume that the oil drop which is being dropped on a water surface so that it may spread is originally perfect sphere. So it is spherical in shape. So in the calculation of its volume, then we shall employ the formula that gives us volume of a sphere. And the volume of a sphere mathematically is given by 4 out of 3 pi r cubed. Therefore, the oil drop is having a diameter of 0.05. So before we determine even the volume, we first of all have to change diameter to radius, and again from centimeters to SI units, which are meters. Therefore, we first of all divide 0.05 by 2 to make it radius of 0.025. Then again, we divide this one by 100 to make it meters, such that the radius now is 2.5. So the radius is now 2.5 times 10 power negative 4, but now in meters. So now we substitute 4 out of 3 times pi. I use 3.142 multiplied by the radius, which is 2.5 times 10 power negative 4. Then this one, we are going to raise it to power 3. We cube the radius. Therefore, when we substitute in the calc, we're going to get 6.5 times 10 raised to power negative 11, and these are meters cubed because we have already changed to SI unit. Then part 2, area of the patch. Now the spherical oil drop spreads to form a circular patch. Now that the patch is circular, then we get its area by using the formula that gives us area of a circular surface, and this will be pi r squared. Therefore, we use a pi of 3.142 multiplied by, this is diameter, so we divide 15 first of all by 2, 7.5 centimeters, and we further divide by 100 to make it SI units, which is 0.075, and we square. So when we square, then we multiply by 3.142, we're going to get 0.01767 meters squared. That is the area of this patch. And finally, part 3, we are told to find the size of the oil molecule. It is very important to know that when we are having a drop that is spherical, this drop spreads until it occupies a big area. And now the assumption we made, or we make after the spreading of this drop, is that it spreads until it is 1 molecule thick, such that there is a thickness in this circular patch, and the thickness here is 1 molecule. Therefore, now this patch is assumed to be cylindrical, such that it has spread to have a patch which is circular, but the thickness now makes it cylindrical because a circular cross-section and a certain height gives us a cylinder. Therefore, it is cylindrical such that the height of the cylinder will give us the size or the thickness or the diameter of one molecule. Therefore, for that matter, then we will say the volume of the oil drop we had calculated in Roman 1 is equal to the volume of the circular patch, or volume of the same drop after it spreads to a circular patch. Now we can have the cross-section area, which we have already calculated, multiplied by their known height to give us the same volume the drop was having when it was spherical. So we can say volume of the drop is equal to volume of the patch after the drop spreads into a patch, such that the volume of the drop, which is already determined, is 6.546 times 10 power negative 11 meters power 3. This will be the same as volume of the patch, whereby we will say cross-section area multiplied by the thickness or the size of the molecule, such that we will have the cross-section area, which is already known, then we multiply with their known thickness to get volume of the patch, such that now to remain with T, then we will have to divide in your calculator 6.546 multiplied by 10 power negative 11, and we divide this one with 0.01767. So this will give us 3.704 multiplied by 10 to the power of negative 9, and these are meters. So the thickness of the molecule, or other, the diameter of the molecule or the size of the molecule, is given as 3.7 times 10 to the power of negative 9 meters. Finally, we are told to state two assumptions made in B, part 3 above. So the assumptions we are making in B above is that 1, volume of the drop is equal to volume of the patch. We're also assuming that the drop is a perfect sphere, and we are also assuming that the drop spreads until it is 1 molecule thick.